Hello everyone, welcome back to the channel. This is second video of the topic probability. In first video we have learned about the basics of probability, and in this video we are going to complete with the concepts of probability. Next video will be previous year questions on probability, and as I've already mentioned, there were only 3 questions from probability topic in last around 8 to 10 years. So not a very high probability topic as per the CSAT exam goes. That is why your basics should be ready, so that if any question comes, if any basic question comes, you should be able to solve it, right? Okay, let's starting with the second video on probability. Till now we have learned is what is probability. Now today we are going to see there are going to be 2 events back to back. How are we going to calculate the total probability? Back to back as in, suppose there are two movies. There are two movies which are releasing this weekend. Suppose movie A of Shah Rukh Khan and movie B of Salman Khan, right? So what is the probability that after watching movie A, people will watch movie B, right? So these two events are dependent on each other, right? So that is what probability of multiple events comes in, right? So let's start with this addition theorem. This you have already seen in set theory. What it says, the probability. So again, this is A event. A event means probability of what is the probability of A happening? Event A. Event A means what is the probability people are going to watch Shah Rukh Khan movie, right? And there is another event, that is B. B means people who are watching Salman Khan movies, right? So now what does this represent? So if I say this part, only this part which I am coloring till here, only this much area, this is the part where people are only watching SRK movies, not Salman Khan movies. And in this area, if I am coloring this area, this is where people are watching only Salman Khan movies and not Shah Rukh Khan movies. And this area in the middle, this area is where people are watching both the movies A and B, right? Now, what does the addition theorem says? Probability of A or B means what is the probability of people watching any of the movies? I don't care. Is it Salman Khan movie or Shah Rukh Khan movie? Any movie. That is probability A or B is given by what is the probability of A? Means how many people are watching Shah Rukh Khan movie. This is just an independent event, right? Plus probability of B means what is the probability people are watching Salman Khan movie, minus probability A and B. And B means they are watching both. So probability of probability of watching any movie, if it is either Salman Khan or Shah Rukh Khan, does not matter. The probability of a person watching any of the movies is equal to probability of watching A movie, that is Shah Rukh Khan movie, plus probability of B, that is Salman Khan movie, minus probability of A minus B. I hope this is clear. Probability of A minus B. This is a basic set theory. If you want to go into deep of this, we have already covered this in the part of set theory. There you will understand this topic better. And for now, we are just understanding the formula, that is probability of A or B is equal to probability of A plus probability of B minus probability of A and B both, right? So now moving on. This is the question. This is the application of what we have learned in the last topic. From the first 30 digits. What are the first 30 digits? That is 1 to 30. Find the probability that a selected number is divided by 3 or 5. Does not matter if the number is selected. What is the probability that it will be divisible by 3 or 5? It could be divided by 3, it could be divided by 5, right? Does not matter. So that is, we have to find the probability of A or B is equal to probability of A plus probability of B minus probability of A intersection B, or means probability of A and B. Now, what is A event? A event is that it is divisible by 3. And between 1 to 30, how many numbers are divisible by 30? 3, 6, 9, 10, oh sorry, not 10, 12, 15, 18, and so on till 30. You will find 10 numbers, right? But what is event B? Event B is it is divisible by 5. So what all numbers that are divisible by 5? 5, 10, 15, 20, 25, 30. Only 6. And A and B means A and B means divisible by both 3 and 5. So what are the numbers that are divisible by both 3 and 5? Could it be 3? No. Why? Because it is divisible by 3 but not by 5. Could it be 5? No, because it is divisible by 5 but not 3. So first number that is divisible by both is 15. Second number that is divisible by 4 is 30. So how many numbers are divisible by both 3 and 5? That is 2. So now, right? I hope this is clear. Now, what is the probability of A? Probability of A is that number is divisible by 30. So 10 such numbers are there. So 10 divided by total outcome, that is 30. Probability of B is 6 by 30. And probability of A intersection B is 2 by 30. So now what is probability of A or B? Probability of A or B is 10 by 30 plus 6 by 30 minus 2 by 30. So you will get as 10 plus 6 minus 2, that is 14 by 30. Right? So 14 by 30 is the answer. So out of 30 numbers, 40 numbers will be such that are divisible by either 3 or 5. Right? Either 3 or 5 means they are divisible by 3, could be divisible by 3, could be divisible by 5, or could be divisible by both. Right? So that is what we have calculated in this question. I hope this is clear. Now moving on to the second part, next part, that is independent events. Independent events is such that outcome of one event has no impact on the outcome of the second event. Right? What does this mean? Let's take an example. Suppose I am eating ice cream today. This is just an example. I am eating ice cream today. Does this event has any outcome on the probability of me drinking coffee after 6 months? These are two different events. They have no impact on each other. So they are totally independent of each other. Means two events are totally independent. They have no dependency on each other. Let's take another example. Suppose there is a deck of 52 cards. I take out one card, that is probability of taking out one card is 1 by 52. I hope this is clear. Now, how many cards are left with you? 51. What I do? I put back that card. So again it will be 51 plus 1, that is 52. Now again the deck is the same. I have replaced that card. Now extract one card. Will first event, that is taking out a card, will have any impact on B? No. Why? Because that card has been put back into the deck. So that is why the second event is not suffered by the event number A. So that is why whenever we are replacing the card, so these are the independent event example, right? Now, second thing, dependent events. Dependent events means, suppose I am eating an ice cream today, and what is the probability that I will get sick tomorrow? So I will have a fever tomorrow. Yes. Why? Because eating ice cream today might increase my chances of getting sick tomorrow. So these two events are dependent on each other. Right? Now, let's take again that example of cards, 52 cards. I take out one card, so probability is 1 by 52. I do not replace that card, and the deck is again 51 cards. Now, the probability of taking out another card from this deck is 1 by 51. Why? Because whatever card I am taking out, suppose I take out the card King of Hearts. So in the second event, I will not have King of Hearts. I cannot have King of Hearts. So the first event is affecting the outcome of second event. So these are the dependent events. I hope this is clear. What is independent and dependent? Now let's see what conditional probability is. Conditional probability in case of dependent events. What are dependent events? That second has effect on one. So suppose A event has happened and after that B has happened. A event has already happened. Suppose it has rained today and B. What are the chances what are the chances of getting a rainbow in the sky? So first event has already happened. What are the chances that B will happen after A has happened? That is conditional probability. So if you see this thing A by B, this means that A, what is the probability of A? What is the probability of A happening after B has already happened? Means B has already happened. Whatever is there in the denominator, that has already happened. What are the chances of A happening now? You can recall the example of card without replacement. Here we have already taken out a card first. Then after that we are checking the probability of taking out another card. So another card, what is the probability of taking out another card when the first event has already happened? That is conditional probability. So probability of A by B means B has already happened. What is the probability of A now? So how the formula for this is probability of A and B both happening divided by whatever is there probability of B. I hope this is clear. So again I am reading this one. Probability of A happening after B has already happened is equal to probability of A and B both happening divided by probability of B happening alone. That is the formula for conditional probability. We'll see few examples on it. Don't worry. You just have to remember this formula. Very important. So uh, conditional probability is one of the few formulas in probability you have to know. Right. Now moving on. Independent events. See, probability of A happening after B has already happened. Now, probability of A happening after B has already happened. That was probability of A and B happening together divided by probability of B. Now I'm asking you, suppose A and B are totally independent, means A has no effect on B. So probability of A happening after B has already happened is probability of A. Why? Because these are two independent. They don't have dependency on each other. So B has already happened. That will not affect the probability of A. So probability of A, again I am writing it again. Probability of A happening after B has already happened is probability of A happening, means A happening alone is the same probability, that is A divided by B, means after B has happened, what is the probability of A happening? That is again PA. Why? Because A is not affected by B happening. That is the definition of independent events, and we have learned that probability of A by B is probability of A. Right? So this is statement number 1. Now, if I ask you what is the formula for this? PA by B is PA and B divided by PB. Now rearranging this, probability of A by B multiply by probability of E, taking B on the other side, is equal to P of A and B. Now what is PA by B? From 1 we know that PA by B is PA. So probability of A and B means A and B both happening is probability of A dot probability of B. Means in a case of independent events, probability of both the events happening is equal to probability of A happening multiplied by probability of B happening. That is what the independent events formula is. This is totally different from the conditional probability. Why? Because two events are not affected by each other, or they are not dependent on each other. I hope this is clear. Now let's see this formula, this question, and that is where we are going to use the example of independent events. Right? Now A man and a woman are appearing for the interview. Probability of man selection is 2 by 5 and women selection is 1 by 7. Interesting question, good question, and important question, right? So, a man and women appears for the interview. Probability of man selection is 2 by 5 and probability of women getting selected is 1 by 7. Find the probability that only one of them will be selected. So, let's first calculate probability of only man getting selected. Man getting selected. So, probability of only man getting selected is probability of man, probability of man getting selected multiply by probability of no women getting selected. Are these two independent events? Yes. Why? Because man getting selected and then after no women getting selected, these are independent. That is why we are using the formula of multiplication. So, what is the probability of man getting selected? 2 by 5. Now, what is the probability of no women getting selected? So, probability of women getting selected is 1 by 7. Probability of no women getting selected is 1 by 1 minus 1 by 7, right? Because the total probability is 1. So, subtracting 1 by 7, that is the probability of women getting selected. So, 1 minus 1 by 7 is giving me the what? It is giving me the probability of no women getting selected. So, 2 by 5 into solving this, you will get 7, 6. So, this will be 12 by 35. First part is 12 by 35. Now, what is the probability that only women getting selected? Only women getting selected is probability of women getting selected multiply by probability of no man getting selected, right? What is the probability of women getting selected? That is 1 by 7. Probability of no man getting selected is 1 minus 2 by 5. So 1 by 7, 5, 5 minus 2, 3. So that is 3 by 7, 5 is 35. So 3 by 35 is the probability of only women getting selected. 12 by 35 is the probability that only man is getting selected. Now the probability of only any of them getting selected, either man or women, is probability 1, that is 12 by 35 plus addition theorem. We have already learned this. So 12 by 35 plus 3 by 35, since they are not dependent on each other, they are two total different events. So that is 15 by 35. We have already learned in the additional theorem in the permutation and combination part. You can go there and check this. So this is the final answer. 15 by 35 is the answer where only one of them is getting selected. Not both, only one of them getting selected, right? So moving on. This is the last question on this one. Independent events. So there are 3 Indian players, 3 Indian, 4 Australian and 5 English players. So there are 3 Indian, 4 Australian and 5 English players. So how many total players are there in the selection? So suppose IPL bidding is happening. So there are 3 Indian, 4 Australian and 5 English players. So there is 12 players in the auction. Now you are selecting your team and you have to find the probability of such an event where your first player is an Australian and second player is an Indian, right? Now, first player is an Australian and second player is an Indian. No, first tell me, probability of Australian getting selected is what? Suppose let's select the first player. What is the probability of that Australian will get selected? 4 out of 12. Why? Because there are 4 Australian players out of 12 players. So those chances of Australian getting selected is 4 out of 12. Now, after event 1 has happened, how many people we are left with? 3 Indians, 3 Australians now and 5 English. And that is 3 plus 6 plus 5, 11. So 11 players are left. Now I have to select second Indian player. Now this has already happened that Australian is already selected. Now what is the probability that Indian will be selected after Australian? After Australian has already been selected, what is the probability that Indian will be selected? That is 3 out of 11. Why? Because 3 Indian players are there out of remaining 11. So 3 by 11. Right? Now, what is the probability that A event means first Australian is selected and B is selected? Probability of A and B is equal to probability of A by B multiply probability of B. Can you remember this formula? Yes, but I've just taken B from the denominator and taking on the other side. So probability of A and B both happening means first pair of Australian getting selected and second pair Indian getting selected is PA by B dot PB. So what is PA by B means probability of Indian getting selected after Australian, that is 3 by 11 multiply. What is the probability of B? That is probability of B. B means suppose B is just Australian getting selected. B means Australian getting selected and A means Indian getting selected. So don't get be confused. So what is the probability of B means in Australian getting selected, that is 4 by 12. Can I write it 4 by 12 as 1 by 3? Yes. So you will solve this. So the answer is 1 by 11. So 1 by 11 is the probability that first Australian will be selected and second Indian will be selected. So that completes our probability topic. That was all the theory you need to know for probability topic. Now we are going to do previous year questions. We'll have three previous year questions where you will learn the application of this probability, and that will complete our counting principle part. Counting principle consists of two topics, that is permutation and combination, and the last topic, that is probability. So that's all for this video. If you have any doubt, post them in the comments, and best of luck. See you in the next video.